Okay, time to talk about our last biogeochemical cycle, which is the hydrologic cycle. So let's go ahead and jump in and talk about water. Okay, so you probably already know a little bit about the importance of water, but we're really going to focus on the importance of water in this biogeochemical cycle. So why is water so important? Well, we're 70% water. So water is important to us because it keeps us alive. It's also important because it moderates our climate. The high specific heat of water allows it to maintain temperatures very consistently. Water sculpts the land through erosion. It removes and dilutes wastes and pollutants. And as we're going to talk about today, it moves continually through the hydrologic cycle. This is just for perspective. If the big blue globe here were to represent all of the water on Earth, this small blue circle would represent all the fresh water, and this teeny tiny little circle here would represent the available fresh water. All right, so let's talk about that distribution of water. So when we look at the total global water, over 96% of the water on Earth is in the oceans. A little bit of it is in saline groundwater and saline lakes, and only 2.5% of the water around the globe is fresh water. And that is an important number and one you need to know. So 2.5% fresh water. If we were to break down that fresh water a little bit farther, we would see that almost 70% of it, 68.6% of it, is locked up in glaciers and ice caps. 30% of it is in groundwater, and that means only 1.3% of the fresh water on Earth is in surface water and other fresh water. Let's break it down one more time. So of that 1.3%, when we look at it carefully, we'll see that 73% of that is in ice and snow, 20% in lakes, the rest in soil moisture, swamps, marshes, rivers, and streams. So that means that overall only 0.02% of the Earth's water supply is available to us as liquid fresh water. So that's a really, really small amount. Water is crucial to our lives, and so it's important that we protect, conserve the water that we have available to us. All right, let's talk about the water cycle. So this is the last of the four biogeochemical cycles that we need to learn about. We're going to start with water in its liquid form in freshwater, rivers, lakes, streams, and in saltwater in the oceans. So this is in the liquid form. That water can then evaporate, and it goes from the surface water into the atmosphere. There are two more ways that water can go into the atmosphere. The larger one of them is what we call evapotranspiration, or simply transpiration. And that's the process where plants, through the process of respiration, break down glucose and produce carbon dioxide and water. That water then evaporates, hence evapotranspiration, and joins the rest of the water in the atmosphere. In a few cases, you will also see water in the form of ice, usually glaciers or snow caps, that goes straight from the solid form into its gas form, and that process is called sublimation, but that is a tiny, tiny percent. So all of that water that is now in the atmosphere can now condense, and it forms clouds. So those clouds then have precipitation that can come in the form of ice, snow, or rain. And when that precipitation hits the surface of the earth, if it's in the form of ice and snow, it can accumulate. If it's in the form of rain, then we have a couple of options, and one of them is runoff. When the ice and snow melt, we can also have runoff. And so runoff is when the water does not penetrate the soil, but simply runs off into surface water. Some of the water, however, is going to penetrate the earth, and we're going to call that infiltration. So infiltration is the process where water penetrates the soil. If it penetrates deeply and goes into the underlying rock, then we call that process percolation, and that's how it enters groundwater. Groundwater can be taken up by plants, or it can actually seep out into other surface water as well. So that's our water cycle. From liquid water to gas through evaporation, evapotranspiration, sublimation, or even occasionally in steam from volcanoes, back into a liquid form through condensation into clouds. Then we have precipitation, which leads to either runoff or infiltration and percolation. And then our process starts over again. All right, so let's talk about some water vocabulary that's going to be really important. We're going to start with groundwater. In groundwater, the precipitation infiltrates the ground and gets stored in the soil or in the rock that underlies the soil. We also have runoff, so any water that does not sink into the ground, does not penetrate or percolate, and does not evaporate into the air, but simply runs off into bodies of water is considered a runoff. And we have a couple of different mechanisms for runoff. It can simply be if there's a saturated surface, then the water will simply flow over the surface and into bodies of water, or if it is on if the infiltration capacity is overwhelmed, then it can run off that way as well. All right, so let's talk about watersheds while we're talking about runoff. So a watershed is the land area that delivers runoff, and along with that runoff, sediment and any undissolved substances to a stream, a river, or a lake or a bay. So a watershed is an area that's defined geographically. There are usually defined boundaries. These tend to be ridge lines. On one side of the ridge, the water will flow down in one direction into a particular lake or stream or river. On the other side of the boundary, it's going to flow away into a different body of water. Okay, so the water table, you hear talk about water tables around here fairly often. The water table is the level below which the ground is saturated with water. Our water table here is very high because we're so close to sea level and because we have a lot of water underground. Okay. Underneath our water table, we have a couple of options. We have aquifers under the water table. So remember, water table is that line below which the soil is saturated. That saturated soil is called an aquifer. So we can either have an unconfined aquifer or a confined aquifer. When we talk about aquifers, generally the mental image tends to be a cavern that's filled with water, and that's an oversimplification. It's more like a sponge. So if you guys think about a sponge, it has a lot of little holes, and so then when you fill it with water, all those little holes get filled up with water. You can squeeze it in the water, it'll come back out. An aquifer is very much like that. It is porous rock with lots of little spaces for the water to fill in. It can have sand, it can have gravel, it can be bedrock. It is an area that groundwater flows through. We have two different kinds of aquifers. We have unconfined aquifers. An unconfined aquifer is permeable straight through the water table. Water can flow into it. Any water that percolates down into the soil can enter the aquifer. A confined aquifer, on the other hand, is bounded above the aquifer and below the aquifer with less permeable beds of rock, which means that there are limited areas that water can enter the aquifer. So in this image, the confined aquifer only has this one entry point. Because it is bounded, the water tends to be confined. It tends to be under pressure. It also makes these aquifers much more difficult to replenish from precipitation. If you have a confined aquifer and it's under pressure, then you tend to have what are called artesian wells. This means that a well drilled down into that confined aquifer doesn't need a pump. The pressure of the aquifer itself will push the water up into the well. When we have a well that just goes down into the water table, which is pretty common around here, those tend not to be artesian wells. You have to have a pump in order to get water out of that type of a well. Okay, so that pretty much covers our hydrologic cycle. Make sure that you can label an unlabeled picture of a water cycle, so you need to know all of those pieces and parts. There is an example here, and there's one on your notes as well. As always, let me know if you have any questions, and I'll be happy to help.